Hello, today I'm going to cover rational numbers. I'm on page 215 in the textbook. Recall that natural numbers are from the set 1, 2, 3, 4, where ... means it continues without an end. I always tell my students that when we think of natural numbers, think about the numbers you learned when you were a kid. So I currently have an 11-month-old, and when she starts to learn her numbers, the first number she'll probably learn is the number 1. So these are numbers that we are naturally learning from when we're a child. From natural numbers, we learn about whole numbers. Whole numbers are just like natural numbers, except we are adding in the 0. Okay. This year we learned about integers, so now we're learning about positive and negative numbers that include the number 0. And today we're talking about rational numbers. So a rational number is any number that can be written as a fraction where the denominator cannot equal 0. So here's a nice graphic organizer for us. So the first thing we've learned when we were real little were natural numbers, so like 1, 2, 3, and 4. Then we learned about whole numbers, which are natural numbers, except we now include the number 0. From there, we learned about integers, which include negative numbers. And today, we're learning about rational numbers. So it's any number that can be written as a fraction, where the denominator cannot equal 0. So here's an example of how to graph some rational numbers on a number line. So we have 2 and 25/100, which would be right over here. Negative 1 and 3/4, which is between negative 1 and negative 2. And we also have the number 0. So let's go ahead and try graphing sets of rational numbers. So I'm on page 216. Okay, graph the set of rational numbers on the number line. So step 1, find the integer boundaries in the set. So I'm looking for the smallest number in this set and also the largest number. So the smallest number I see is negative 1 and 8/10. And the biggest number I see is 2 and 3/5. So I need boundaries, like where I'm going to stop and start on my number line. So I'm going to include negative 2 and a positive 3. Okay, so that means that's where my number line is going to start and end. Okay. Step 2 says graph the rational numbers. So in order to do this, it's really best to make sure that our fractions look like decimals. We want to convert them to decimals when we graph it. It just makes things easier. So we're going to graph negative 1/5, but let's turn that into a decimal first. So the easiest way to turn that into a decimal, I'm going to go ahead and change my denominator to 10. So to get from 5 to 10, I'm going to times it by 2. I'm going to do the same thing to the numerator. 1 times 2 is 2. So the reason why I did that, so now I have this equivalent fraction of negative 2/10, and negative 2/10 is really easy to write as a decimal. I get negative 2/10, where 2 is in the tenths place. So do something very similar with this. Since my whole is 2, I'm just going to bring that 2 over there. That's taken care of. Okay. So to get from 5 to 10, I'm going to times it by 2. I'm going to do the same thing for my numerator. 3 times 2 is 6, so I get 6/10. So 2 and 3/5 is the same thing as 2 and 6/10. All right. It says now we can graph on the number line, label each point with the value in its original form. So negative 1/5 is the same thing as negative 2/10. So they put it right here at negative 2/10, but they kept it in its original form. And then a positive 2 and 3/5 would be way over here, which is the same thing as a positive 2 and 6/10. And again, they kept it in its original form. So they went ahead and graphed everything for us. So now it's our turn. So let's go ahead and graph these rational numbers on the number line. Okay. The first one is negative 1 and 7/10. And to write that as a decimal, it's really simple. We get -1 and 7/10. The 7 goes in the tens place. Okay. On the next one, I have 1 1/2. And then I have 2/5. This one, I'm going to go ahead and make an equivalent fraction so I can turn it into a decimal. So I get from 5 to 10, I times it by 2. So I'm going to do the same thing to the numerator. 2 times 2 is 4. I get 4/10, which is the same thing as decimal 4, 4/10. And the last one is already done for us. We get -6/10. Okay. I'm going to go ahead and count and see what they are breaking our number line into. So it's going up by fifths. Okay, so the first one, I have -1 and 7/10. So I have -1 and 7/10. So -1 1/2 would be like right here. So 7/10, I'm going to place like right over here. The text reminded us that whenever we graph it, we want to graph it in its original form. Okay. The next one I have is 1 1/2. So here's 1 1/2 would be right here. Okay. I have 4/10. Okay. That would be right here. 2/5. And then the last one would be -6/10. Just be right here. All right. I am over here on example 2. Find the absolute value of rational numbers. So in our previous section, we learned the absolute value is the distance a number is away from 0 on the number line. So it says graph -53 4/10 on the number line. Let me go ahead and read this for you. Sorry, I'm getting ahead of myself. If the cave entrance has an elevation of 0 meters, evaluate the absolute value of 53 4/10 to determine the number of meters a hiker would descend to reach the lowest point. Okay, so it says graph -53 4/10 on the number line, and they already did that for us. How many units from 0 is -53 4/10? So they're basically asking us how far away is that from 0 on the number line, and it's 53 4/10. So the hiker descended 53 4/10 meters. The Miller family is having an in-ground pool installed. The deepest point will be -9 and 7,500 feet below ground. If the ground has an elevation of 0 feet, evaluate the absolute value of -9 and 7,500 to determine the depth of the pool. So the absolute value of -9 and 7,500, they're asking us how far away is this number from 0 on the number line, and it's 9 and 7,500 feet. Okay. I'm on the next page. Comparing rational numbers. To compare rational numbers, you can compare the signs as well as the magnitude size of the numbers. If the signs are different, the positive rational number will always be greater than the negative. We learned that in our previous section when talking about integers. If the two signs of rational numbers are the same, you can graph the numbers on a number line and compare them, which again is what we did in our last section. The greater numbers are graphed farther to the right on the number line. So let's go ahead and practice comparing. Compare -50 100ths and 12/25, -12 25ths. So step 1, in order to compare fractions and decimals, they have to be in the same form. So let's go ahead and convert this fraction to a decimal. So in order to do that, you have a couple options. You can do 12 divided by 25, or I'm going to make an equivalent fraction. I'm going to set my denominator to 100. To get from 25 to 100, I'm going to multiply it by 4. Do the same thing to the numerator. 12 times 4 is 48. So I get negative 48 hundredths, which is the same thing as negative 48 hundredths. So negative decimal 48. Okay. Now I can graph it on the number line. So negative 51 hundredths is right here, and then negative 48 hundredths is right there. And again, they kept it in its original form. Number negative 51 hundredths is further to the left in the number line. That means it's smaller. So negative 51 hundredths is less than negative 12 over 25. So let's compare another one. Compare negative 3/8 and negative 413 thousandths. So again, when we compare fractions and decimals, they need to be in the same form. So I'm going to go ahead and change that fraction into a decimal. Okay. So my go-to method is to always make an equal fraction where I have a denominator of either 10 or 100 because that's really easy to change to a decimal. But there's nothing I can do to 8 to get it to have 10 or 100. So I'm just going to use long division. So I'm going to do 3 divided by 8. Your denominator is always going to be your divisor. So it's going to be a long division problem. I'm going to ask myself, can 8 go into 3? The answer is no. So I'm going to add a decimal followed by a 0. And notice how I bring my decimal to my answer up top. I'm going to ask myself, can 8 go into 30? It can go into it 3 times. 3 times 8 is 24. When I subtract, I get 6. Bring down another 0. 8 goes into 67 times. When I subtract, I get 4. Bring down another 0. 8 goes into 45 times. So negative 3/8 is the same thing as a negative 375 thousandths. So when you compare that, we know that negative 3/8 is going to be greater than negative 413 thousandths. Because when I compare these two decimals, 3 is smaller than 4. So this decimal, if I were to graph it on a number line, would be further to the right. So if I were to graph that on a number line, I know that negative 3/8 would be closer to 0 than negative 413 thousandths. Okay. On the next page, it's showing us an example on how we can order rational numbers. So they said the first step is to write each number in the same form, which we've talked about. So we want to make sure that they're all fractions or they're all decimals. It's really easy just to make sure they're all decimals because when you do fractions, a lot of the time you have to make sure that they all have the same denominator, which, as you know, with fractions can turn into a lot of work. So a lot of times it's just easier to make sure that they're all in decimal form. Use this for step 2. It says use the signs of the numbers, place value, or number line to compare the numbers. Step 3 is to order the values from least to greatest. So to order the set of numbers of 1/4, negative 375 thousandths, negative 17 over 50, and 3/10, they went ahead and graphed them all on the number line. Again, the least value is farthest on the left, and the greatest value is all the way furthest on the right. So the set of numbers in order from least to greatest is, we have negative 375 thousandths. Sorry, that bell's ringing. Followed by negative 17 over 50. We have 1/4. And then we have 3/10. And to write it from greatest to least, we're just going to write it backwards. So we have 3/10, 1/4, negative 17 over 50, and negative 375 thousandths. All right, so I love the textbook, but I'm not a fan with how it shows us the answers all the time. So I really like this example because they want us doing the work. So let's go ahead and try this one together. So order the set from least to greatest. So the first one's already done for us as a decimal. The second one is not. So notice they want us to change this to a decimal. So again, let's make an equivalent fraction. So we're going to make this into a 100. To get from 25 to 100, we're going to multiply by 4 times 4. 22 times 4 is 88. So this is going to be negative 2. I'm going to bring over that negative 2 and 88 hundredths. And for this one, I love this fraction, 1/10, because when I write as a decimal, I just put the 1 in the tens place, negative 2 and 1/10. All right. The textbook one again went ahead and graphed it for us. We could have done that, but did it for us. So they put negative 2 and 46 hundredths right over here. Negative 2 and 88 hundredths, which is over here. And again, they wrote it in the original format. And then negative 2 and 1/10 is over here. So the set of numbers in order from least to greatest is negative 2 and 22 over 25, negative 2 and 46 hundredths, and negative 2 and 1/10. Now it says order them from least to greatest. Okay. This one's already done for us. So was that one. This one we just did 2 and 1/10. This one was a negative 2 and 1/10, but we know if we just take away the negative sign, we still will get 2 and 1/10. And this last one, we have 1/5. We actually did this one on the other page. We'll do it again. So we have negative 2 and 1/5. We're going to go ahead and make an equivalent fraction. To get from 5 to 10, we're going to multiply it by 2 times 2. 1 times 2 is 2. Bring over that negative 2. So we get negative 2 and 2/10, which is the same thing as negative 2 and 2/10. So whenever I am comparing a list of decimals, I like to order them by comparing them by lining up the decimals one on top of the other. So stay with me. I'm going to put 2 and 12 hundredths. Right underneath it, I'm going to put negative 2 and 1/10. Notice how my decimals are on top of each other. Then I get 2 and 1/10, a positive 2 and 1/10. And then I get negative 2 and 2/10. So again, we could have made a number line. I'm going to show you a different way. So notice how all of my decimals are on top of each other. Okay. We know negative numbers are always going to be the smaller numbers. So I'm looking at these two right here. I have negative 2 and negative 2 in the ones place. Go to the tenths place. Okay. I have a 1 in the tenths place and a 2 in the tenths place. So that means this one would be our smallest number. This would be next. Okay. Now I have 2 and 1/10 and 2 and 12 hundredths. So since this one went to the hundredths place, I'm going to add a 0 here. So now I have 2 and 10 hundredths. Okay. The next smallest number, they both have a 2 in the ones place. They both have a 1 in the tenths place. This has a 2 in the hundredths place. This has a 0. The smaller number is this one, followed by 2 and 12 hundredths. So to write it from least to greatest, it would be negative 2 and 2/10. In the original format was negative 2 and 1/5. The next one is negative 2 and 1/10, which was written like that. Then we have positive 2 and 1/10, which is written like this. And then our biggest number is 2 and 12 hundredths. All right.